Okay. So, hello, good evening, and welcome. So, we have been holding this sessions since November last semester, while we were wrapping up last semester. So, we thought we would discuss because artificial intelligence is now the topic that everyone is talking about, and with a India AI mission, I think that's the plan that everyone should talk about. So here we are, and the technology development pace is so fast. So I think we need to make the conversation and just understand each other's perspective, share thoughts, and that was the intent. We had some fun in November offline meeting, and so we thought we'll have this small group chats this semester. And Pranav is our guest today. Pranav is a student of BITS Pilani Goa campus, and now he's doing his PhD. So Ananya will be introducing him. As usual, we have the discussions at first, and then we um, throw open the floor to the audience for asking questions and for discussions, really, not quite asking. Yeah. Okay. And with that, I hand over to Ananya. So over to you.
Thank you so much. Thank you, ma'am, for introducing Pranav briefly as well. If I may add on to that, just a brief introduction for everybody else. Pranav graduated from Goa in 2021 with a degree in electronics and communication engineering. So he's a doctoral researcher at the University of Oxford, and he has a strong background in engineering as well. He is a neuro AI researcher working on fundamental problems in safe AI and AI for healthcare. Pranav, would you like to expand a bit on that and tell us more about the interesting work that you're pursuing now?
Right. Thank you so much. First of all, it sounds like a really good student initiative, and I'm very happy to be here. So yeah, I tend to I tend to sort of explain myself as a neuro AI researcher. And what this field of neuro AI basically means is both neuroscience and artificial intelligence are sort of very sort of quite linked together in a way, and you can take insights from artificial intelligence to solve problems about neuroscience and sort of model human cognition and advance what we know about human and animal minds. But then also we can take insights from neuroscience and see how we can improve the current AI systems and so on. So it's sort of a back and forth between these two almost parallel fields, and it's so inherently it's quite interdisciplinary. And within sort of the neuro AI field, my specific focus throughout my PhD, now I'm nearing the end of my PhD, has been on sort of the safe learning in humans and machines. So here I'm focusing more on the problems about safety that are shared by humans and machines alike. So both and here when we talk about AI, we are thinking in terms of I'd like you to just consider like a robot that you can interact with. So any robot or any AI with a physical existence ought to have some instincts for safe exploration and self-preservation. Um, and that's what I've been sort of focusing on, how we can take insights from AI to understand how humans and animals do these two things, safe exploration, self-preservation, and if we can take these insights back and create some sort of a safer robot. Yeah.
If I can have a follow-up question, I meant to
Yeah,
ask,
sure.
can
Yeah.
you tell us what safe AI means in the context of your work? Like, is it data safety or physical exploration safety?
Right, right. So it's more of the physical exploration safety, but that's what I've been working on right now with my PhD. So but I'm also looking at the other side of things, as you mentioned, and the way I like to rather characterize it is in this way. and that other part is the AI for healthcare bit that you mentioned. So um, the majority of the work that I've been working so far is this problems which are shared by humans and AI alike. So what we are, the way we are using any sort of machine learning, or any sort of insights from AI is to model human cognition and how, um, yeah, the safety or safe exploration or self-preservation itself. But the other way nowadays, how it's, like, and it always has been, machine learning is also being used as a tool, and then the safety concerns that arise from human computer or human AI interaction itself, uh, for example, large language models, they are being used as a tool rather, in most instances, rather than a model of human cognition. And what we are concerned more about is not the safety of the robot or like the AI system, but rather safety of the human interacting with the, tool or a AI system or a chatbot or something like that. So that is what I'm currently, sort of slightly also starting a new project on, which I can talk about later. But it's more about, that bit is more on the application side of things. So it's less fundamental and it's, more applied. Yeah.
Yeah, that makes sense. Thank you. So, since you mentioned the robot exploring and then using safe mechanisms to make sure it's learning correctly, um, since this is based on a cognitive model, not all learning in humans is exploration based, right? So, where does that contrast come about?
So when you say not all, learning is exploration based, do you refer to like exploration exploitation dilemma, or what else are you thinking of?
Yeah, like exploration, exploitation, and also humans have like a basis belief system, which I
Mm.
don't think robots generally have. So I think that bias factor might also play a role in human exploitation. I'm not sure.
Right, right. Like, yeah. So you mean not all learning is through trial and error, but
Yeah.
rather we sort of have, sort of general knowledge baked into us. We have grown up. So yeah, I do think, majority of safe learning, is through vicarious trial and error. Like, you don't actually need to make mistakes yourself. You just see other people make mistakes, or you've seen growing up. Um, okay, that's what happens if you do that, and I better ought to avoid it. So we do create these very explicit world models of, if I'm in this state, or if that person, or generally someone is in the state, and they take this or that action, then it leads to this sort of outcomes. So I think then that falls into a very model based, like everyone is creating a world model of what the repercussions of their actions are. um, and I think that is one of the ways to, like, yeah, that is definitely one of the ways to achieve safety. It feels like, and it's something I've been trying to inch towards. I haven't found the answer, but what we know so far is humans and all animals use a very wide range of, safe behaviors. One is something very simple as like reflexes. These are quite, like primitive. You won't be able to do very interesting things with that. There's no model of repercussions of actions, but they are really fast. Like, you don't need to, like, you're not thinking. It's so in instances when you're being chased by a tiger, the reflexes are quite helpful. But at the same time, if you look at escapes, like, you might know, there's, a Nat Geo, um, documentary, and you can see, like, and I forgot what I think it's an iguana which is freshly hatched out of its shell, sort of escapes and can find its way, as like avoiding, around 20 rattlesnakes or some sort of snakes, and jumping off cliffs. So that is something like, there's evolutionary mechanisms which have baked us into it. I'm more like, I work within reinforcement learning, so I think of it in terms of baked in value functions. But it's quite interesting because then in that sense it's more than reflexes. We have these innate capacities, or not all knowledge needs to be in a way that you can verbally put it and you have seen happen, where you just know it growing up, or maybe even innate through evolution. And that knowledge not only is really like hardwired, it is hardwired yet flexible in a way. Like the iguana, for example, knows all of these actions of, okay, I need to run away from danger and avoid an obstacle and jump off a cliff, but it can also flexibly compose all of these motor repertoires, which it's probably trying for the first time. Yeah. So I feel like there's this wide range, what is called in the literature as this threat imminence continuum by Dean Mobbs. It's basically from a very model based, so um, whenever there's a threat happening, a very model based solution would be, okay, if it is not very impending danger that I need to care about right now, then there's things like rumination. You can think about what's going to happen, and so on. But then on the other side, there's these reflexes and very things that you need to do right now. So yeah, sorry. I'm not sure if I answered the question. It sort of drifted away a bit, but yeah.
No, it was very nice. But yeah, Ananya will pick up from here.
Yeah, thank you. That makes sense. Yeah. So, on the topic of learning, since you were working with reinforcement learning in general, here are we testing the difference in like decision-making mechanisms between models, robotic models, and human cognition?
Sort of, you mean to ask, are we finding differences between how a robot would do some task and how humans tend to do it?
Yeah, yeah.
Yes, right. So, well, a robot would do whatever we bake into it in a way. So, what I would take from that question is sort of how a standard reinforcement learning, or a standard any other, if you um, follow any other sort of any other engineering framework, but whatever the standard way does it, and how do humans sort of slightly differ from it. And that's one of the things that I've been working on in my first work of my PhD. It was, so basically what you can think of the standard reinforcement learning is, you just get rewards and punishments. Negative rewards can be considered punishments, and then you try and maximize your reward or minimize punishments. And that's sort of um, and we can call that system as the instrumental system, as it's sometimes called in the conditioning literature. Sort of, you have an instrumental goal that you're trying to achieve, and the goal rewards you. But then what would happen is, like, there's sometimes these, as I said, reflexes is one of these additional sort of a vestige of evolution, but it's sort of also useful. Similar to that, we also have learned reflexes, which is sort of Pavlovian reflexes, both to approach and withdraw. If you're being rewarded, you have an innate bias to approach a stimulus. I'm going to sort of skip through a bit because we are short on time, but and then with withdrawal, it's when we have this thing called Pavlovian fear withdrawal, as in, if you're expecting punishments or like electric shocks or something, then there's an innate tendency to withdraw from this stimuli. And one of the things is that is not, like, there's no reason for that to exist in a robot, is one of the things we might feel is it's not a part of the standard RL way. But from time and time again, we know that we, like, humans have not only one controller but multiple controllers competing for behavior or action. So one of these systems is this Pavlovian fear withdrawal. Even within the ways of action, there's always been this habitual and goal-directed dichotomy, which we have been, like, the neuroscientists have been studying for the past 20-25 years or more, at least computationally. So this is something like a Pavlovian fear withdrawal is a very it's habitual, but it's even beyond habitual. It's very primitive. But what we found is it sort of helps with safety at the cost of some sample efficiency. So that is one of the ways we sort of try and see if humans do a task slightly differently from what we would expect from uh, n- a normative framework. I think the word for rather than Stanford is standard is like what is normative and why are we doing something different than the norm? Yeah.
Yeah, that makes sense. Thank you. So, slightly different from this, I was just wondering, since you work in AI for healthcare, could you elaborate a little bit on the specific task that we might be looking
Right. So the task that I'm looking at, and I've sort of just like applied right now for a grant, is on basically large language models are bound to get integrated in a lot of healthcare scenarios. And one of the things that we are focusing on right now is patient clinician interactions. Um, UK has this system called NHS. It's a public healthcare system. Uh, it has many benefits, but one of the sort of issues with it is it's very hard to find any time with the doctor at all. It's completely overwhelmed. There's a shortage of staff, and it's yeah, it's quite overwhelmed. So you might get to see your especially if you have a chronic pain condition. So we are currently focusing on a small subset. Well, it's not quite a small subset actually. Around 5.3 million people in the UK. So that's I forgot the percentage. It's probably somewhere around 15% are currently being prescribed opioids or opioid treatment in for chronic pain. And just to give a brief overview, is that um, opioids usually do not. It works for a few people, but in general, it has led to an opioid epidemic or opioid crisis in the US. So it's currently there's a lot of focus on deprescription, trying to reduce the opioid prescriptions unless it is really necessary, and that is something the clinician needs to take into account. So you really need time with the clinician. You need to be able to discuss what your problems are as a patient, what your top three concerns are, and if opioid, and then the clinician will decide if the opioids are actually going to solve your um, concern, or is it better addressed by some other treatment like physiotherapy, also mental health sort of therapies and so on. So and there's many more. So the problem is you only get to see the clinician maybe once in 3 months for like 15 minutes, and half of the time is gone in just trying to get to know what have you been up to for the past 3 months. And that's not quite efficient in the first place. And nice guidelines have already suggested that or already sort of almost demanded that more digital pathways to be included in this setting. And we are just studying opioid because I think it's an ideal test case where it's bound to get um, applied, and it's something the collaborators that I have here have expertise in handling for many years. But the way we are trying to include large language models in this sort of setting is quite applicable to any other healthcare setting where you want to improve any sort of patient clinician interaction or efficiency. So the bit we are trying to do is how can we make this, if an LLM is going to be used in this sort of interaction to facilitate this interaction, how we can make it safer in any way. So that falls under what is called um, yeah, it's sort of a risk, or a systemic risk in AI. I think that's the term for it. What it basically means, like if an AI is being used improperly in many of these scenarios, then it sort of can lead to quite a large problem. Like, for example, in finance sector, it would be something like financial crisis. Over here, it could be like exacerbating the opioid crisis and so on. Um, so yeah, that's what we are working on. Yeah.
When you say the AI would facilitate this conversation
Mm.
between the patient and the practitioner, the AI isn't replacing the practitioner, is it? It's just
Mm.
acting as a bridge.
Yes, yes, and I think that is the right way to do it right now, and it's also something that is something we can see actually taking place in next 5 to 10 years. Um, Replacing the clinician is something quite I don't think is the right thing in this scenario, and it has a lot of risk associated with it. So one of the main concerns, there's lots of papers written on about it, is like one of the concerns about AI stem from higher agency, and so with AI systems, like that is one of the reasons it might be risky. So the first intervention itself is to reduce agency. So one of the ways to reduce agency is like, can we use AI to just or like, to be specific, language models to just facilitate this discussion and help improve the um, clinician's role. So the way we are trying to do it is, one is, can we just have um, a patient talk with the chatbot and figure out, the chatbot will help figure out the top three concerns of the patient, which will then be relayed to the clinician beforehand, and that'll help them improve the discussion. Because currently, from like PPI, public patient engagement, we have figured out that patients already are not happy with the clinician. They don't have the trust, because every time they see a new clinician, they don't know what the problems are. There's hardly any time. So maybe in one of these things, the trust can be improved. Another is yeah, another is, of course, time efficiency can be improved. Um, and there's another, like, you can use a separate chatbot to just keep a track and check up on the patient every once in a while, maybe daily or once in a week, to see what they've been up to. And that is one of the ways it can be used. And this is sort of not specific to the opioid application. It can be to any sort of healthcare application, I feel like. Yeah.
Yeah, that makes sense. Just one last follow-up question on
Yeah,
this.
sure, go ahead. Yeah.
Yeah. The thing with chatbots is, to what extent do you think user trust would increase even with the chatbot? Because I know that LLMs to a large extent don't necessarily hallucinate anymore, but because that was a condition up until even a year or two ago, that's still something I worry about, where, oh, maybe the LLM might hallucinate and add in extra information, which is then relayed to the clinician. So are concerns like that still in
Yeah.
mind, or is that something we've eliminated?
Yeah, that's certainly in mind. So that's one of the things that we are looking at. I think there's like yeah, three main big issues that we are looking at, and one of those falls into one of those categories, three categories. Um, so the bit is that um, one of the first category is, for example, um, there's this sort of concern about over reliance of experts start to over rely on the AI system. In education, it could be experts start to, or even like students just start to over rely on AI, that they don't actually learn the concepts themselves. That's a concern. Similar to that, I think it could also happen like the clinicians are just too overwhelmed, so they start relying on the AI way too much, and what sort of downstream effects this could have. And one of the cases, like if a AI hallucinates, then it's sort of going to affect, it sort of feeds into that. Another sort of case within that is, well, patients might realize, if I say certain things, it's going to feed certain things into the summary, which is highly likely to make the clinician think, okay, maybe I should prescribe them opioid. So they might learn to sort of tactfully engage with the system in a way which was which was not intended by either of the parties, neither the developer, for instance. So these are a lot of so the whole safety problem with any sort of integration of LLMs into the world is not just a technical problem; it's a socio-technical problem, as it is referred sometimes in the literature. So you can have a system which does not make any errors. It's very fault tolerant. It's technically safe, but if it is misused or does something that does not align with human values, um, then it can create quite unprecedented damage. The other two categories I'll quickly tell about is the second one is how does this AI do this discounting of patient concerns in a sense? What I'm thinking of discounting as in temporal discounting in RL, because reinforcement learning. For example, if the patient comes, okay, I want opioid, it's going to solve my immediate concern, it's going to help pain relief, but it's probably not good in the long run because there's been significant amount of deaths because of opioid overuse. So there's this sort of trade-off between, do I treat the current concern or something in the future, and that's something a clinician has learned to do it. um, but sort of, yeah, an AI may not be able to do it. We don't know how an AI would respond. It might be quite flaky in a sense. Yeah, it might not have like a common policy that adheres to. The third one is this concept of emotional dependence, which sort of ties back with the trust bit that you talk about. Um, so what one of the hypotheses is that maybe that trust develops in a different way, that it leads to an emotional dependence. For example, some of these patients, unfortunately, are not very socially connected, especially if you have disabilities. And there's maybe no one looking up on them every day. And if a chatbot does, then it's highly likely a vulnerable population might develop a emotional dependence, or at least is at risk of doing so. And it can have quite we don't even know the exact effects this could have. Um, so what we are trying to do right now is just test it out on a small subset, like a patient subset of maybe 10 patients with an interaction for about a few weeks. And any insights we gather from that then would lead on to like future studies with larger cohorts.
Yeah, that sounds great. Thank you. I think I've asked a lot of questions, so ma'am, if you would like to ask a question, please go ahead.
Yeah, and very interesting questions and equally interesting answers. Thank you, Pranav, for very nice insights, and Ananya for the questions. So I think my usual question is that worry about the power consumption and sustainable technology of the future. And we are all thinking about our Earth now and how to collaborate with it while we are developing technology, humankind is. At the same time, we don't want to destroy the Earth in the process. So the machines that are being used consume a huge amount of power. All of us know that. What are your thoughts on that?
Yeah, that is undeniably true. It's using a lot of power, and well, the easy way out is just to blame it on the large corporations. But we as researchers, I think what we need to do is find better algorithms. We do not yet have efficient algorithms, and well, there's a lot of people who believe in scaling, and scaling is the future, to scaling more and more compute, and we'll get better results. But that seems to be it at least is under doubt at the moment with GPT-4 and so on. We haven't seen quite the same advancements as we saw from GPT-2 to 3 and so on. So many people are saying there's a data wall or ceiling of some sort. Um, and there's people like, for example, I think Ilya Sutskever, they have a startup called SSL, Safe Superintelligence, and they're sort of trying to find alternates to transformers. There's people who are like, for example, one of the bits that I sort of currently believe in, and one of my works. So I worked a bit on predictive coding as well during my PhD, which provides one of the alternate ways to do backpropagation. So you can do backpropagation while performing it with some sort of a local plasticity. It does not outperform backpropagation in most instances because it performs quite similar to that. In certain small instances of small data sets, it seems to outperform backpropagation for like tasks like continual learning and so on. But so that's not still quite there yet, and we don't know if that is the way that will find an algorithm, because the only way to solve the crisis is well, one way is of course through policy and regulations, but I'm not qualified enough to talk about it. So all I can say is if we come up with a better algorithm, which is undeniably better than other ones, which is efficient, power efficient, then yeah, capitalism would need to use it, because if it's like that's what happened with DeepSeek, right? It was undeniably better, and people had to shift. They shifted, yeah. Um, One of the other ways is distillation, model distillation. I think people are already doing that. I think so. Um, for example, you start off with a bigger model and then sort of train a smaller model to capture at least like around 70, 80, 90% of the knowledge with a much fewer parameters and so on. And maybe these can be used at on edge devices. So you don't need to actually do like talk to the server and complete the whole computation at the server, but it's all done on edge devices. That I think that's a decent solution, but that is something the industry is going to do regardless of what researchers do. I think so, yeah.
Yeah. Okay, thank you. That makes a lot of sense. Thanks for your thoughts on that. If anyone else wanted to say something, feel free to just raise your hand, then we can accommodate. In the meantime, I think Ananya would want to ask the next. So over to you, Ananya.
Right. So I think when I asked other people if they had questions to raise, someone brought up the matter of potential for AI to look into natural disaster detection. So is that
So, sorry,
something
could you
that
repeat it?
Yeah,
um, yeah.
just
couldn't hear you,
yeah?
Ananya.
Is this better?
Yeah.
Yeah.
Okay, I'm so sorry about that.
So,
Okay, so I asked others if they wanted to contribute questions that perhaps I could ask. Um, and someone mentioned that they wanted to explore the potential of AI across a number of fields that, sorry about that, that aren't as tapped into as of yet. So one of the questions was asking about potential implications of using AI in critical domains. And they wanted to ask about healthcare or military and governance as well. So do you think
mhm.
there's potential for AI to expand its range in these cases?
Yes, the obvious answer is yes. But again, in most cases, it comes with safety risks. Um, yeah, like for the example, for example, the one I mentioned in like just an example in healthcare that I can talk about, that there's safety risks associated with it. Um, so it needs to be done with yeah, with caution in a sense. um, it's the same is probably with military. Again, it's a bit outside my circle of competence. uh, so yeah, because I haven't worked on anything like that. uh, one of the things I find quite exciting, because it's not quite clear what a critical domain is, and I feel science itself is quite critical in a sense. If you come up with a new discovery, um, even if it's a fundamental discovery or a basic science discovery, it could lead to some translation, for example, which could have a massive downstream impact which we are not aware of yet.
Yeah, true.
And there's a DeepMind work recently on AI as a co-scientist, sort of as a tool which you can interact with, and it'll sort of help you come up with alternate hypotheses, I think so, and sort of aid you with discovery, make it quicker. And I think that is something I'm personally quite excited about. How that will plan out. Yeah.
Yes. Yeah, thank
Yeah.
you.
Yeah.
Yes, please, Ananya, continue.
So, ma'am, I think there was another question. Would you want to ask?
Yes, yes. So someone asked, I think, from the audience that, yeah, again, this is a random question, though. I mean, not actually within your expertise area, but if you have any opinion, Pranav, feel free to. If not, we can just have a generic discussion. So the question was that there was an earthquake in Myanmar very recently, and do you see any potential for AI in helping with natural disasters? And I think these are already in news flashes. How people. So were you aware, or are you aware of any specific details in this regard?
Not with the earthquake in Myanmar or how it could be used.
Yeah.
Yeah. Well, one of the things that's often used, or I think it's already used, is to rescue people, to find who needs to be rescued. It's often hard to find people. So with aerial sort of drones, they'll often find, like, use um, classic segmentation, computer vision methods to just find people who need to be rescued. But the segmentation is quite difficult because it's the way it'll show up is not like a usual person you'll see in a YouTube video. Which is often the training data for most of these segmentations. So there's needs to be a specific data set for fine tuning, which is often done. So rescuing is one use cases. There's also, not everything needs to be very AI. I feel like in many of these scenarios, like there are other ways to improve the rescuing as well, which may not always use AI. Um, Again, maybe another thing is sort of finding who needs to be delivered what, to sort of commodities or supplies to help, help improve the condition and so on. So it's some sort of like, mm, what's it called, yeah, some sort of like a traveling salesman problem, and so on. So I think that there's always ways to find yeah, some use case. I'll need to think more to come up with something. Yeah. Yeah.
Yeah, but thank you, Pranav, for sharing your thoughts. Yeah, so because that was a generic question, and there are these news
Mhm.
flashes which I think I came across just one where they are using the segmentation thing and to understand. But and as you rightly point out, not so. Of course, I mean, as um, with time we adapt to technology. So yes, everyone needs to be aware of artificial intelligence, but at the same time, we also need to be aware that we shan't just think about AI just for the sake of
Mhm.
it.
Yeah.
There
Yeah.
are actually other potential means to risk, so to serve or cater to these emergency situations such as earthquake or floods,
Mhm.
natural disasters, or even landslides, unannounced for heavy rains or flash floods. So these are some of the things that yes, AI could help, but of course there are several other ways to tackle the questions, and these are yeah. Okay, so thank you. And with that, can I ask the audience so other students of the lab? So please, you can ask any question that is in your mind today.
If I may ask another question,
Yeah,
Please
sure.
do, Ananya, while we wait. Yeah.
you mentioned that you don't see the need for AI in everything, right? So I agree with that sentiment, and I think this is a discussion that the rest of us had before, but I was just wondering about your opinion on the increasing role of AI in creativity. So I think a few weeks ago, the Studio Ghibli animation trend just
Yeah,
soared and then died back down, which
yeah.
seemed very unnecessary because a lot of artists believe that AI had no space in their creative bubble. Um, what are your, what's your take on
Yeah, I think that was a wonderful marketing gimmick played out by Sam Altman, if I were to be frank. Um, y- Wonderful from a business point of view, and I think he's quite adept with it because he has worked with the startup accelerator. I mean, he led it for quite a long time, so he knows how to grow startups, and I think this was one of those things. Um, I personally do not find it appealing at all. Like this AI made creativity. I personally sometimes sketch digitally on my in my free time as well, and in general, I feel like it's the whole it sort of a bit undermines what um, the emotions that go into sort of creating a piece of work. I mean, Hayao Miyazaki, the Ghibli sort of Ghibli um, director, was actually I think I forgot what it's called, but it's basically he was a child born during war times. You cannot come up with sort of those animations and like even like some of those simple scenes of a market area have taken more than 1 year to sort of sketch. So I think it can quite imitate uh, AI can imitate human sort of creative, but I don't know whether it's creative or not, or whether we want it or not.
Mm.
Yeah, creativity also, I guess, like beauty lies in the eye of the beholder. So yeah.
Yeah, excellent point actually. That emotion thing, it undermines the emotion, the effort, the creativity. Um, yeah, terrible, terrible times. But anyhow, okay. So Vibhav has a very interesting question
Oh yeah.
here. So he has written actually in the chat space.
Yeah.
Um, so I can read it for the audience if anyone were not able to read it. Is that how can reinforcement learning models inspired by neuroscientific principles such as dopamine based reward systems be leveraged to develop more personalized and adaptive treatments in mental health care?
Yes, thanks, Weber, for this question. I think this is a really good question. Like, because I mean, I really like this question. This is something sort of computational psychiatrist. There's a emerging field of computational psychiatry, which is very quite like tightly linked with the whole computational neuroscience field. Um, have been thinking about for many years, and like a lot of people where I'm working right now also work on like think about these things. um, and the way to do it, I think, or at least the general, if you like a very broad approach which people follow, is you create these sort of different models of as I said, um, since you're already aware of the dopamine-based RL models, the seminal work by Schultz, Dayan, and Montag, which sort of really put the role of reward prediction error into sort of mapped it to phasic dopamine. From that, we now have this sort of mapping between, okay, we can explain a bunch of these neural responses with these equations, and then we try and find and we know that these learning rules then are used to change and adapt behavior, so sort of learn which actions are better and which aren't. So what we can do is then we can create very specific tasks, some sort of a computerized task where which involves rewards and punishments of some sort. So and then we fit different kinds of different iterations of these models um, to humans solving this task. Like we collect data of humans like patients solving these tasks, and then we fit a lot of these slightly different models to see which one fits best. So for example, a very slight difference could be, okay, instead of having just one learning rate, we'll have different learning rates for positive and negative prediction errors. And that's enough. Like to capture some sort of optimism or pessimism biases. And if you have a higher learning rate for positive prediction errors, like something really exceeds your expectations, then you're quick to change your value about something, or at least some expectation about something. But if something is so you're quite optimistic, where something undermines your or sort of undershoots what you um, were expecting, then you're resistant to changing your value. You still think, oh, maybe something might get better. So sort of this imbalance between optimism and pessimism can be captured, and that's just one example. So then this could be a biomarker of some sort, a computational biomarker, or as it is called sometimes in computational psychiatry, is this sort of computational phenotyping. So just like how there's normal biological phenotyping, um, we can map, okay, and then this can be then used to stratify sort of patient populations into different categories. For example, there's everyone, for example, has, let's say, for example, depression. The depression is not a not everyone, but like everyone, like for example, the subset that, let's say, if my patients as a clinician, all of them have depression, but the depression is not a homogeneous condition. It's very heterogeneous, for example. um, Within that there could be multiple subsets, and now clinicians have stratified it for more than 100 years as, okay, anhedonia is one of the kinds where you do not feel, or at least the patient does not feel um, any pleasure from the rewarding stimulus. And so that's a very specific kind one. And then you can try and find, okay, which of these models predict anhedonia to some extent. um, then you can try and sort of map out and say, okay, which sort of treatment should someone get. And maybe a computational, or sort of this computational phenotyping is a better way to figure out who might also, for example, benefit the most from certain treatment than others, if that makes sense. For example, what we can do is then also, if let's say you give different drugs. So one of the drugs that's used is levodopa for depression treatment, or even like any some sort of SSRI. I think it's quite common, the serotonergic reuptake drugs. So you can try and see how, let's say, you have a patient do a task, give the drug, so that's like an intervention, have them do the task again, and then you see, okay, if the behavior changes, how does that reflect in the computation model? Then you can say, okay, maybe the learning rate changed, or the one of the reward or punishment sensitivities changed. And then you can say, okay, maybe the effect that this drug seems to be having is on, let's say, learning rate parameter. And if we already stratified people based on these parameters, okay, people who have this imbalance between positive and negative learning rates, just for example, then you might think that then you can predict, okay, there's high chance that this drug might help people who fall into that bucket of that sort of computational phenotyping, if that makes sense. Sorry for the very long-winded answer. And please feel free to ask a follow-up question if it's not clear.
I think that was needed because it was a good question, so it needs explanation. So, and you explained it very nicely, Pranav. Thank you. Vibhav, was that so? You can please, yeah, it's quite clear. Thanks, is
Okay,
what he says. Yeah.
thanks.
Okay. Thanks, Vibhav, for the question. It was a very nice question. Thanks for asking. I think it was very relevant. Also, anyone else wanted to ask? And please, oh, there is no, that's Vibhav's message, I think. Yeah. Okay. So if there are no more questions, Ananya, would you like to, and Pranav, any overall
Yeah.
thoughts that you would have and or like to share with in this theme? Um,
I'd like to ask a question. Like, yeah. What are each one of you like sort of most interested in right now? Maybe at the intersection of neuroscience and AI, or just AI in general. Like, what is it that excites you, gets you out of bed and to work on something in the
yeah,
morning?
so
Yeah.
that's a question for you. Excellent. So you see, who would want to go first? Saranya, would you like to just say in very brief, 3 or 4 lines, what you are doing? And Alicia and Karen might actually tell what you have been doing very recently. Very nice stuff, no? No other way, or are they there at all? I can't see also. If you are all are here, then please, you can also write in the chat space. You don't need to unmute. Yeah. In the meantime, Pavan, did you have anything to say, or yeah, would you like to say something about your? Yeah, so this is Pavan.
Using biological. So the Pawan says, are you using any biological mechanism or brain models in your AI approach? Yes. So yeah. So reinforcement learning is more of like, let's say, AI to neuro. And your question is, I think, more of like neuro to AI, or just neuro in neuro AI. Sort of, are we using anything from insights from biology in itself? And I think I did not get so sort of, yeah, I did not explain uh, the predictive coding bit a bit in detail. So one of the projects that I've sort of working on, it's almost finished. We will get it out soon. Is how we can use. Well, the problem is self-preservation. You need to, in order to preserve yourself, you need to know when you're injured. So you need to have this, as a robot, or even humans, they need to have a concept of an injury state to be able to detect injuries. And for a robot, which is doing a certain sort of stereotypical movement again, like some task repeatedly, the simplest way is to in order to find anomalies. So anomaly is like an injury or abnormality. You need to have a model of what normal behavior itself looks like, and what the normal task space during these things looks like. And the biological mechanisms that we are using this is the biological mechanism that we're using is, well, predictive coding. But the biological plausibility of it is that the good part about predictive coding, even though it has uh, s- like, it comes a bit from artificial intelligence, if you, or rather pattern recognition, is that all of the prediction errors are local, unlike backpropagation. So for backpropagation, you need to um, sort of perform the actual backpropagation, then perform the gradient descent. So you'll need to sort of do the forward pass, find the errors at the very last step, backpropagate the errors to each of the intermediate layers, and then perform the gradient descent. So you don't need to do that in sort of predictive coding, because all of the errors are already in those respective layers locally. And that sort of makes sense biologically, is it aligns with um, sort of Hebbian plasticity as well. And you only have information that's on both ends of the sort of synapses which are connecting. Um, though I must admit, the biological plausibility is quite at a superficial level. If you talk to someone who is even more biologically inclined, um, so, for example, someone might argue, recently there's a lot of neuronal studies showing, um, maybe Hebbian plasticity is not the most widely used plasticity. There are other learning rules which are biologically plausible and sort of being used. So yeah, so that is something that can be worked on in the future. But so that's one of the ways we are using with predictive coding. We can use it to create this model of what normal behavior looks like to then detect abnormalities. Yeah, cool. Vibhav has a comment. Oh yeah, thanks. Yeah.
Yeah. Thanks for the question, Pavan, and thanks for the answer, Pranav. So, yeah, Vibhav has also written something that's exciting. So, Pranav, you can read
Oh,
if
yeah.
you want to.
Should I read it out loud or just?
Oh, yeah, it's fine. I'll read it out
Okay,
loud.
it's fine. Okay, cool. Thank you.
So, something that's exciting about AI for me is the search for a master algorithm that solves almost all problems in a given domain. Recently in India, someone created AI on Bhagavad Gita data. So, like the possibility of AI God, is that so? I didn't know that helps guide humanity in the right direction. Oh my God, that's is fantastic to imagine for me. Is it, Vibha? Okay, maybe we disagree. I will. I don't know the full thing though, so I shouldn't comment. I think so. Yeah, Pranav.
Yeah, that's the concept of the master algorithm in a given domain is quite appealing, though it depends on what the given domain is. Um, the AI God one, I don't know how I feel about it. But yeah, I think the quest for master algorithm is something that has been there for as long as we know, since the beginning of time. I feel like yeah, uh,
Mm, for all
in
practical.
all yeah, yeah. So,
Yeah, no, you go, Pranav. I'm so sorry. I think I
no,
didn't.
it's fine.
I
Yeah,
was not.
yeah. So yeah, I just feel like the concept of a master, um, well, it's algorithm because in computer science, but master something, master theory, master framework has always been, and it's an and it consumes researchers for some of them for all of their lifetime. It becomes their life's work. I mean, Einstein was quite fascinated. Like he wanted to come up with the master theory, and he did it for almost his entire life. Currently, professors like Carl Friston have also, tried to come up with a master algorithm in a way, in their own way, with the active inference. Um, to some extent, I think the given domain is the bit that needs more focusing than the master algorithm, because I feel like if it's a theory of everything, then it's a theory of nothing. So we need to have a clear boundary of what it is and what it can predict, and beyond which. So it also often is helpful if we can make falsifiable predictions. So if you can falsify the theory, that is less likely with algorithms, I feel like, but at least we will know for which cases the algorithm is the best one to go for, and where we should use something else. And yeah, so I think the given domain bet is quite important. Yeah, cool.
Okay, yeah, thank you. But we were very nice question, I must say. So I think that can make a whole another hour of discussion you know to say the
Yeah,
least.
yes,
Yeah.
indeed.
Okay, but thank you. It was a fantastic discussion. Thank you all for chipping in questions, and Pranav, thanks for very insightful responses and discussions and thoughts. Thanks for making the time for the lab and the students, especially. And Ananya, any last um, thoughts?
Yeah, thank you so much for joining. I'm really glad I got insight into everyone's questions and opinions as well. So thank you, everyone. I really enjoyed these discussions.
Yeah, likewise. Thank you for arranging this, and yeah, thanks a lot. Yeah,
Thank you then. So we can disperse. Thanks everyone for joining in. Good evening and good afternoon to Pranav.
yeah,
So bye bye. We meet
yeah. Good evening.
next
Bye.
time. Yeah. Bye bye.
Good evening. Thank you.